All right, let's jump right in. Have you ever wondered how an app gets from a developer's computer to, running flawlessly for millions of people all over the world? For a long, long time, this was one of the toughest nuts to crack in technology. So today, we're going to break down the two technologies that completely changed the game: Docker and Kubernetes.
So, why is this such a big deal? Well, this quote really nails it. In today's world, software is the business, plain and simple. If your app goes down, your business goes down. The stakes are just incredibly high.
To really appreciate how good we have it now, we have to take a trip back in time to what the source material calls the bad old days. And trust me, it was a time of huge headaches and frustration, where just getting a piece of software to run was a massive achievement. The old way of doing things was, well, it was simple but unbelievably wasteful. I mean, picture this. You'd buy this giant, expensive physical server, and its only job was to run one single application. Most of its power just sitting there, doing absolutely nothing. And this created this incredibly slow, super expensive, and just totally unsustainable way of working. Oh, the accounting team needs a new app? Okay, buy a server. HR needs something? Guess what? Buy another server. You can see how this got out of hand fast. Costs just spiraled. Then, finally, we got our first real game changer, the virtual machine, or VM. Now, this was clever. A VM let you take one powerful physical server and digitally slice it up into multiple, smaller, virtual servers. So now you could run a bunch of different apps on just one machine. It was a huge leap forward. But each of those VMs still needed its own complete, heavy copy of an operating system. So virtual machines fixed the one server per app problem, which was great. But their sheer size and all that overhead created a new problem. And this is what really paved the way for the next evolution in thinking, an idea that was way more efficient and powerful: the container. Okay, this is the key difference right here. With a VM, every single app is lugging around its own full operating system. But with containers, they all cleverly share the host computer's operating system. They only package up the app itself and the bits it absolutely needs. This makes them incredibly light, super fast, and you can move them anywhere. All that extra baggage with VMs led to this idea of the VM tax, or you could call it the OS tax. It's all that wasted processing power, wasted memory, wasted disk space, all just to run a separate operating system for every little app. It was this huge hidden cost. Containers, they just wiped that tax right off the books. Now, the idea of containers had been floating around in the Linux world for a while, but honestly, it was really complicated to use. And that's where Docker came in. Docker was the company and the tool that just changed everything. They created a super simple, user-friendly way for any developer anywhere to package their apps into containers. They basically made it for everybody. The absolute fundamental building block in the Docker universe is something called a Docker image. The best way to think of it is like a perfect, locked-down recipe or a blueprint. It's the single, neat little package that has everything, and I mean everything, the application needs to run. The code, the tools, the libraries, the whole shebang. And this idea is an absolute game changer. Because with a Docker image, that classic developer excuse, well, it worked on my machine, that just disappears forever. If it runs in the container, it's going to run exactly the same way, everywhere, every time. But you know how it goes in tech. You solve one big problem, and in the process, you often create a completely new one. Docker made it so easy to create containers that suddenly, companies went from managing a few dozen VMs to trying to juggle thousands of these tiny little containers. And a whole new kind of chaos was born. All of a sudden, you're faced with these new, urgent questions. Who's keeping an eye on all these containers? How do they even talk to each other? What happens if one of them crashes at 3 in the morning? Who's going to restart it? Let's be real, trying to manage a whole fleet of containers by hand is, well, it's impossible. It would be a complete nightmare. You need a system, some kind of automated brain that can handle deploying them, scaling them when traffic gets crazy, and just making sure they're always healthy. You need an orchestrator. And this is where the second hero of our story makes its grand entrance: Kubernetes. It started inside Google, but now it's this massive open source project that has become the undisputed champion of container orchestration. And the name is actually perfect. It tells you everything you need to know. Kubernetes is the Greek word for helmsman, the person steering a ship. And that's exactly what it does.
It steers this massive fleet of containers, keeping everything in order. And a little fun fact, that's where the nickname KAS comes from. It's K, then 8 letters, then S. Pretty clever.
So what does this helmsman actually do? Well, it pretty much puts everything on autopilot. It deploys your software for you. It automatically scales your apps up or down depending on how many people are using them. If a container fails, it automatically replaces it. They call this self-healing, which is amazing. And it intelligently spreads out the work so no single container gets overwhelmed. Now, here's a little technical detail, but it's pretty important. Kubernetes doesn't actually manage individual containers one by one. It uses a concept called a pod. A pod is the smallest thing Kubernetes works with, and it can hold one or more containers that are meant to work closely together.
Whew, okay. We have covered a lot of ground. So let's take a step back and put all the pieces together. Let's look at the big picture of how this all works, from a developer's keyboard all the way to the cloud.
At the end of the day, the whole modern process boils down to these 3 simple steps. Step 1, a developer writes their app, maybe using something like Laravel. Step 2, they use Docker to package that entire app and all its dependencies into one of those neat, portable Docker images. And step 3, they just hand that image over to Kubernetes, which takes care of all the hard work of running and managing it across a whole cluster of computers.
So, why does all of this matter? What's the big payoff? It's that this workflow gives you a system that is totally standardized. It works the same way everywhere. It's incredibly scalable, so it can handle millions of users without breaking a sweat. And it's resilient, meaning it can automatically fix itself when things go wrong. And this right here is probably the most important thing to remember from all of this. Docker and Kubernetes are not enemies. They're not competitors. They are perfect partners. A simple way to think about it is this. Docker creates the standardized shipping container for your software. In Kubernetes, Kubernetes is the giant, automated, global shipping network that manages all those containers. So we've walked through this incredible journey from doing everything by hand to this amazing new world of automation. Docker and Kubernetes completely solved the massive challenge of deploying software reliably. And that leaves us with one final big question to think about. What's next? What's the next great automation challenge that developers are going to solve?